Hello my dear students, let us take one more example on bending stresses in the beam. Let us take one T-section example. Two wooden planks 150 mm by 50 mm each are connected to form a T-section of a beam. If a moment of 6.4 kN meter is applied around the horizontal neutral axis inducing tension below the neutral axis, find the bending stresses at both the extreme fibers of the cross section. Here it is given of two planks, means this is a flange and this is web of T section. It's given 150 by 50 mm and here also 150 by 50 mm, and it is given that moment is 6.4 kilonewton meter, and here it is given tension is below the neutral axis. So it is asked to calculate the bending stress at both the extreme fibers, means at the top and bottom, both the places you have to calculate what is the bending stress. So for that, first you have to calculate what is I, because that equation is m divided by I is equal to sigma divided by y. So m, it is there, it is given, that is equal to 6.4 kilonewton meter. Okay, so m is there and I we have to calculate, and sigma, that is also we have to calculate, it is asked to calculate, and y we know, that is once if you get that where is the position of the neutral axis, you will have y value also. So let us take find first I value. How we can find I value? First you have to calculate what is the position of the neutral axis. So let us assume first the position of the neutral axis. This is just assumption. I'll assume here, okay, at the bottom layer. So now what is y bar? Y bar is equal to a1 y1 plus a2 y2 divided by a1 plus a2. So what is a1 here? This I will take, this is the section 1 and this is section 2. So 150 into 50, a1 y1, a1 is 150 into 50, y1 is what is that? Distance from the CG to the neutral axis. Now the neutral axis I assumed at the bottom, so distance from here to here, what is the distance? Still here it is 150. Distance of this CG of this section is exactly at the center, that is at 25 meter. Okay, so this is from here to here. We have to calculate distance from here to here, that is here till here, this is 25, half of 50, so 25 plus this distance 150, so it becomes 175. So 25 plus 150, 175. So this is the section 1. Next I will go to this 2. Okay, so what is that? Area is now 150 into 50 into, now from CG to the neutral axis. Now neutral axis is here, CG is somewhere here. What is the distance? So CG is 150 here, so it may be somewhere here. So distance from here to here, that is a half of 150, that is 75. Okay, so that is equal to y2. So substitute that divided by this is this distance. Okay, from here to here, that is y2, that is 75. 150 divided by 2, that is 75. So divided by a1 plus a2, 150 into 50 plus 150 into 50. So you get y is equal to 125 mm. But I considered this from the bottom side. So whatever the answer I got, that I will write, that is YB, because I considered the neutral axis at the bottom. So YB is equal to 125. What is YT now? The total distance is 150 plus 50, that is equal to 200. So 200 minus 125, this is 200. Okay, so distance YT is 200 minus 125, that is equal to 75 mm. Okay, so that is from the top. now. So that's why I have marked here. Okay, this is from here, this is YT. From the top it is 75, and this distance is YB from here to here, that is whatever that answer you got, 125. Okay, now we know this is the position of the neutral axis. Okay, this is the position of the neutral axis, that is 125 meter from the bottom and 75 meter from the top. Now you can calculate what is I. I is equal to, what is the formula? I have told in the last example, BD cube divided by 12 plus A into Y square. So BD cube, I consider this first, 150 into 50 cube divided by 12 plus A. A is 150 into 50 into Y square. Y square is distance from CG to the neutral axis. Now the position of the neutral axis is here. Distance from here to here, what is that? 75 minus 25, right? Because CG is located here, somewhere here, that is 25 meter. So I want distance from here to here, neutral axis. Always you have to remember Y is distance from the neutral axis to the CG of that section, that is from here to here, that is 25 here to till here. Total this is 75. 75 minus 25, that is equal to this one is a whole square, because BD cube divided by 12 plus A into Y square. Next I'll go to this section. For this, B is 50 and D is 150 cube divided by 12 plus AY square. A is 150 into 50 into Y square. Now again Y square is distance from CG to the neutral axis. CG is somewhere here. So distance from here to here, what is that? Here to here distance is 125. So 125 minus 75. Okay. So that is equal to distance from CG to the neutral axis. So that is 125 minus 75 square. So you get, when you simplify, you get 53.125 into 10 raised to 6. You just check the answer. I don't know whether the answer is it's correct or wrong. So now we have I value, that is 53.125, and we have M also, that is given here in the previous in the question only, that is 6.4 kilonewton meter, and we know extreme fiber distances, what is YT and YB. So only one unknown is sigma. So how we can write this formula is M divided by I is equal to sigma divided by Y. If you want to find the sigma, we can write the equation like this, M divided by I into Y. Now I am finding first bending stress in the lower extreme fiber, that is here this is Y T I have written, because in the question it is given that inducing tension below the neutral axis. So at the below the neutral axis, that is tension. So here I have written, that's why it is YT. Okay. So you have to consider YD also, BD, Y from the bottom. Okay, so use M is equal to 6.4 into 10 raised to 6 divided by I is 53.125 into 10 raised to 6 into, now this YT means tension zone Y you have to consider, that is at the bottom. So bottom depth is YB, that is equal to 125. Okay, so whatever the answer you get, that is 15.06 Newton per millimeter square, or this is 15.06 MPa. Okay, so this is not there, just 125 is enough. And next, bending stress in the upper extreme fiber. Now you have to, upper extreme, down is its tension, so upper zone is in compression, so we have to use Y from the top now here. Okay, so that is otherwise you can, here only you can change it to, this is from the bottom and this is from the top. Bottom zone is tension and top zone is compression. Okay, so then substitute the values. You have M value, I value, and Y from the top 75. You get 9.04 Newton per millimeter square, or 9.04 MPa. So once if it is calculated, you can draw the bending stress diagram. The bending stress diagram is like this. This is the position of the neutral axis. Okay, this is neutral axis. This is neutral axis. So draw the line from this is top extreme fiber and this is bottom extreme fiber. In the problem it is given that it is tension on the bottom side. So here it is tension, here it is compression. Tension is plus, so towards the right side, and compression is towards the left side. So that direction, and you can write the values also here. Compression, that is on top it is 9.04 and bottom it is 15.06. Here you can write this is 9.04 and this is 15.06. okay, so like this you can calculate both the stresses on top and bottom. This a rectangular section and circular section stresses are same, but in the case of T section and also unsymmetrical I section, stress on top and bottom layer is different. Okay, I think all of you understood. If you have any difficulties we can discuss in the class. Thank you.